Hi friends, welcome back to the MedPg EdgePlus series. Today, as a continuation, we'll be learning about the analytical epidemiology. See, this is a part of the numerical series. Actually, I wanted to do this series of videos because one of the most scared or one of the most feared part of all PG exams is the numerical sides, especially from PSM and pharmacology. So if we tackle these questions, these are one of the most consistent questions also. So when these questions comes in a question paper, we know that this is gonna come. Okay, and we have tried very hard to learn this, but then we always forget. So once you sit in the question paper for the exam, you actually see the question paper and you see such a question, you read through it, and if you're not able to answer then that causes a lot of stress, and that stress can negatively affect your examination and total performance. So I think this is an essential part of the preparation to tackle these concepts very clearly and get it in your head wired, so that whenever and wherever such questions are asked, you will get it easily done. Okay. The numericals in analytical epidemiology include the cohort study and the case control study. Actually, the analytical epidemiology is a very huge topic, and I'm only focusing on the numerical questions that are asked from these areas. So it is my major component is from the cohort study, and of course there is also case control studies. See, before learning the numerical as such, I need to impart some concepts in your head. Why are these things coming by, and why are we trying to do this? Okay. For example, as doctors or as any researcher, what we want to prove, and that question of proving and the answer that you get is what is the funda of the entire thing of analytical epidemiology. I'll tell you with an example. Okay, see, I have a disease called cancer. Okay, for example, lung cancer. I want to know what causes lung cancer because it has been ailing me a lot. Always a doctor, the problem is disease. Please get it wired in your mind, because I want this concept to be as a part of the number of other concepts that I'm going to say. So this is that you as a doctor, the first thing that comes into your mind is a disease. So for a disease, you have number of things. Actually, in my last screening video, I told about when disease comes, we need to prove it by a test. So in that, we compare two tests, okay, to get the outcome for a screening, that is sensitivity and specificity, also the PPV and NPV. So similarly here, we want to know what causes the disease. Okay, that is, the question is what is actually the cause of the disease. To find out the cause, for example, in carcinoma of lung, we have found out that smoking causes it. But before knowing that smoking causes cancer, we had a question. Okay, cancer was found out as a very major disease that is ailing the population, and we wanted to know what causes it. At that time, we arrived at a number of theories by a number of cross-sectional or number of descriptive studies. We found out that in a population, actually, smoking can be a cause factor of cancer. So in that hypothesis that smoking causes cancer, we want to prove it. How will you prove it? We should establish that in a particular population, if smoking is common, cancer should be common. Okay, and in another population, if there is no smoking, lung cancer should be lower in that population. Okay, so that will give us a reasonable evidence saying that smoking causes cancer. But then the next question comes. Okay, that is how you establish. In the first step, you establish the causation. That is the causation theorem. That is, you establish that smoking causes cancer by a reasonable evidence by saying that in one population that smokes a lot, there is a higher number of cancer. In another population that does not smoke a lot, there is a lesser number of cancer. That is step one. So the next question comes, how many times you want to quantify. As far as doctors are concerned, or any researcher is concerned, before telling something to the public, before teaching someone, we want to get down to the numbers. We humans have always represented everything with mathematics. So to get into the mathematics part of it, we want to know the numbers. So the question comes, how much or how many times does smoking has an increased chance of getting cancer when compared to a non-smoker? So always get the Einstein's theory of relativity into your mind. Okay, see, I learn all these things by linking the things that I've studied in my small classes, because the small classes like in our 8, 9, 10, plus 1, plus 2, we had put so much of our heart and energy into studying all these things, so that we have had some concepts there. So if you always link these things, new things, to those old things, it stays in your head. So I have decided that in everywhere, whatever we do to express something, we compare with something else. Okay, we have a normal and abnormal. To study the abnormal, the disease, we have to first study the normal. The normal was the physiology. Okay, so similarly in this phase, what I'm trying to tell you is that we have to compare. We have to compare with the normal population. So the question is, how many times does the population of smoking has cancer than the population that does not smoke? Okay, that is called relative risk. That is called relative risk. That is the first thing that we have to do in cohort study. That is the first set of problems to find out the relative risk. So cohort study helps us actually having three points that we should be doing as numericals. That is the relative risk, the attributable risk, and the population attributable risk. See, the three things are actually very similar names. So you should be very crisp and clear in the concept so that question will not mislead you. Okay, and you will not end up finding out the wrong value. So I've told you that in a cohort study, what are we trying to do? So a little more deeper in the analytical epidemiology so that the concept becomes clearer. See, what is a cohort study? See, I've told you that in a population of smoking, you have to find out that whether there is cancer is higher or not. Similarly, in non-smoker, whether it is lower or not. So what have you done? We have taken two populations, okay, that in one population there is smoking, that is the risk factor, okay, or the exposure, and then there is the other one in which there is no smoking, there is no exposure. So you follow up these two populations to a point, for example, a number of years, and to find out that they are having the disease. So both the population had the disease, that is they reached the end point, that is the disease called lung cancer. So once you take two populations and follow up through a time period, that is you take two particular populations, population A, population B, you follow up through a time period, time to end at A dash and at B dash. Okay, that is the outcomes, A to A dash and B to B dash. This may be both same, that is see a lung in this case. Okay, so you followed up to find the outcome, and that is called a cohort study. Okay, in a cohort study, you are trying to establish that a particular thing is the causative factor of the particular disease. Okay, so you're following up in time, and finally you're comparing relatively to the normal population what the exposure population had a higher chance or a lower chance. It can be of course lower also. That is a protective effect. Okay, so you can say that maybe vitamin C or vitamin E, that is antioxidants, prevents cancer. So if you have a negative association, that is a positive relative risk, that you can say that it is actually protective also. I'll go into that later. Okay, so let's keep that in your mind. So see, that is the relative risk. So similarly, the next question I told you, the first question was the causation, second question was how many times does the population have a higher incidence of cancer. Third level will be how much of this disease is actually attributed to the exposure. See, I've told you that in a population A where there is smoking, okay, and in population B where there is no smoking is actually having cancer. Okay, this may be actually lesser or more, but we know that it's lesser since we already know that, but then it may be lesser or more. Similarly, it may be higher in this. So even we know that even the population without the exposure is actually having the disease. So next question will be how much of this disease is actually caused by the exposure to smoking. Okay, that is the incidence attributable to smoking as a risk factor or as an exposure. Okay, so that is called attributable risk. The risk attributed to the particular factor, that is called attributable risk. How do you find the attributable risk? I'll just show you. It is that we know that in smoking a particular incidence was there. In non-smoking there is another incidence. So just think that if you subtract that incidence from smoking, okay, the total incidence caused by smoking, you subtract the the incidence in the non-smoking population. Okay, so what you get? You get a difference, that is the amount higher due to smoking. Okay, and then you express as a percentage. That is called attributable risk. That is incidence exposed minus incidence non-exposed divided by incidence exposed. See, the denominator is the total exposed. Okay, you are expressing this denominator and the extra that is on the higher, that is you are actually subtracting the exposed from the non-exposed. So from the non-exposed from the exposed. So that is actually giving the extra one, the extra edge, the extra number of disease caused by smoking when compared to the normal population. Okay, where they also have the disease of lung cancer, but the extra lung cancer caused by smoking is subtracted as a product. Okay, that is here. Then let us take as y. Okay, so now we express it as percentage. That is called attributable risk percentage. Okay, it's as simple as that. So you can see that in the graph I have made it very clear. Okay, this is the total exposed. This is the unexposed incidence. So if it was exposed, for example, if I have taken a population of 1000, 100 is having cancer in smoking and 10 is having cancer in non-smoking. Okay, so just imagine that I have subtracted 100 minus 10 divided by 100. That will give me 90%. See, this 90% is actually the total attributable risk to smoking, to carcinoma lung via smoking. See, it is as simple as that. So the next or the fourth and the final level will be applying the entire knowledge that we acquired in the first, second and third level in the community level or in the PSM level. That is how a community medicine physician will be thinking about. You see, just think that we knew that we first found out that smoking causes cancer. Then we found out that how many times does smoking causes cancer than a population that does not smoke. So the third one was that how much of the actual incidence of this cancer was attributable to the factor of smoking alone. That is called attributable risk of cancer of lung to smoking. Okay, so now we want to know that we do an intervention. Okay, we do something like a campaign or we primordial intervention in which we ban the entire like tobacco products, or we in a hypothetical situation we are just eradicating the entire tobacco products from the whole universe. Okay, so we are taking out smoking and tobacco products of the world. Okay, in that condition, if you do that, how much of the actual disease volume will be reduced? So that is the population attributable risk. That is, if you take out the risk factor or the exposure, how much of the disease can be reduced? So that you can say that the total volume of the disease attributable to this particular cause factor, and if you intervene, how much of it can be reduced. That is called population attributable risk. Okay, I hope you got the idea. Okay, if the risk factor is modified or eliminated, there will be so much annual reduction in the incidence of the disease in a given population. That is called population attributable risk. Okay, so we just think about the denominator. See, I told you it is about the population. So naturally, it should be the incidence of the population. That is the total disease in the population. For example, I take a population which of 2000 in which 1000 were smokers. Okay, and another 1000 was non-smokers. Of smokers, 100 got disease. Okay, in non-smokers, 10 got disease. Okay, so what is the total incidence? Total incidence will be 110 divided by 2000. So that is the total incidence of the population. Okay, that is I population. Okay, incidence population. Similarly, what is the incidence among unexposed? Incidence among unexposed will be 10 divided by 1000. Okay, that is the 1000 population that is not exposed. Okay, so if I take population attributable risk, it will be how will I calculate? How will I calculate as the total incidence of the population, okay, minus the incidence in the unexposed divided by the total incidence of the population. Okay, if you work this out, I think this will come as 9 by 11. I'm not sure, just check it out. This comes as 9 by 11. Okay, so that will be the incidence. So if you convert it to a percentage into 100, you will give the percentage of population attributable risk. Okay, so that is just the concept. So if I do some 2 or 3 numericals, it will become more and more clearer. Let's do a question. See, in this question, 100 individuals are diagnosed as with lung cancer, in which a population of 100,000. Okay, out of 100,000 people, 100 are diagnosed as lung cancer. Okay, and out of these 100 patients, 80 were actually smokers. So in the patients, 80 were smokers, and 20,000 of the population were smokers. Okay, so imagine that the total population were 100,000. Out of them, 20,000 were the smokers. Okay, so we have the population A, the population B. The population B is the population A is the population with the exposure. So 20,000 were smokers. Okay, so 20,000 of a study population were smokers. Okay, at the same time total was 100,000. So 80,000 of the population were non-smokers. Okay, just keep it in your mind. And out of the total number of disease were 100. Okay, so out of the smokers, how many were having the disease? Just imagine how many were having the disease. See, 80 were smokers. So the total number of people with disease in smokers in population A is 80. In population B, it will be so naturally 20. Okay, so out of the non-smokers, 80,000, 20 were having lung cancer. Out of the smokers of 20,000, 80 were having lung cancer. So we want to find out the incidence. The incidence in both will be like very simple. Incidence will be a percentage. So 80 out of 20,000 were having lung cancer. That is incidence of among exposed. Okay, incidence exposed. Similarly, 20 out of 80,000 were having cancer. That is incidence unexposed. Okay, so now that we have found out the data, we found out the incidence. Whenever you are getting a study, cohort study, and you are asked to find out any risk, you always calculate the incidence and keep. Okay, so the two incidences we are having. So the level 1, as I told you, level 1 will be the relative risk. What is relative risk? Relative risk will be, see, just leave this question out. We are doing everything. Okay, so just leave the question out. What is relative risk? Relative risk is the comparison between, so we found out that the smoking population has a higher rate of cancer. So how much higher? How will you compare? With the normal one, if you take a ratio, you are comparing. So you are comparing incidence among exposed divided by incidence among unexposed. That will give you, okay, 80 divided by 20,000, okay, divided by 20 divided by 80,000. Okay, that will give you the relative risk. So if you calculate this out, I think it is 16. Okay, just see, I think it comes around 16. So you just calculate and see. Okay, I'm not sure about that. So that is actually the relative risk. Now let us go into level 2 of the questions. Okay, level 2 questions. Now let us go into level 2 questions. Level 2. What is level 2? Level 2 was attributable risk. So what is attributable risk? Attributable risk was that percentage of the illness that is actually caused by the particular risk factor. To find out that, we needed the incidence among exposed minus incidence among the unexposed divided by incidence among the exposed. That was actually, we can see that incidence among exposed. Exposed was 80 divided by 20,000. Okay, minus incidence among unexposed, that was 20 divided by 80,000. Okay, the whole divided by incidence among exposed, that was 80 divided by 20,000. That will give you the attributable risk. So if I am correct, it will come around as 93.75. Please see it yourselves. Okay, comes around as 93.75%. Let's take as 93. Okay, yeah. So that is level 2 or attributable risk. Now let's do the level 3 of the disease. Okay, that is population attributable risk. Okay, so what is population attributable risk? See, I have already defined you. It is actually the next level, the level at which an intervention is planned in society. So if I am saying that if smoking is taken out of the society, then we can say that dash percentage of the illness is also taken out. That is, dash percentage of carcinoma lung will be reduced if you take out the entire risk factor called smoking away from the society. Okay, so that is your planning intervention. So you want to know the benefit you get by doing this particular intervention. That is what you gain by calculating the population attributable risk. So I told you it's a population. So the denominator should be the incidence among the population, because it should include the whole set of the population. And then numerator will be incidence among population minus incidence among the unexposed. Why unexposed? See, I have told you that background, the population A and population B was there. both are having carcinoma lung, but the population B was not exposed. So that means at background level itself, there is an actual incidence of carcinoma lung due to other causes, by genetics or by other risk factors. You're having carcinoma lung. So if you take that in the calculation, it will become a confounder. So you're eliminating that part away from the total carcinoma caused from the population. That is, out of the total lung cancers, you are actually eliminating that small population of people, or big population if it is some other case, population of people who are actually having carcinoma lung even without smoking. Okay, that is called incidence among unexposed. So we calculate this as, okay, the total denominator will be 100 was the total number of cases among 1 lakh population. So we again subtract that, okay, that is 1 lakh of the population minus incidence among the unexposed, that was 20 among 80,000, correct? So you're subtracting that. I think this will come as 75%. Okay, please check it out. It is 75%. So that means that if you eliminate smoking from this particular community, 75% of the carcinoma lung can be reduced. See, that's a huge thing. You are taking out smoking from a population and you're actually reducing 75% of the total incidence of carcinoma lung from that particular population. So that is the attributable risk of the population to smoking with respect to carcinoma lung. See, that is what you finally derived out of the entire exercise, or the entire funda was level 1 was to find out the causation, level 2 was to calculate how many times the smoker gets a chance of having carcinoma than the non-smoker. That is relative risk. From relative risk, we went into the next level of attributable risk, that is how much of the actual carcinoma of lung is attributable to the risk factor called smoking. That is called attributable risk. And then at the level of the community, we had what was the load of the disease that can be reduced by planning an intervention, or if you take out the particular factor out of society, what is the load that can be reduced. That is called population attributable risk, and that we calculate out. Okay, so totally we are having this four levels and 3 levels of problems, 4 levels of concepts and 3 levels of problems. Okay, that is the total thing you have to calculate in respect to or with respect to cohort study. Okay, and case control study also, there is something called the odds ratio or the cross product. It is quite easy thing. The only thing you need to do is to actually calculate or find out the 2 by 2 table. So I think already the video is prolonged a lot, so if I add that also, you become very bored. This is actually the cohort study 2 by 2 table. You can actually do this for a case control study also. Almost everything is same except for this comes as case and control. This comes as case, this comes as control. You just see that. Okay, it's very easy, and try to learn that up. If you're not able to, notify me. I'll try to do a video on that also. Okay, so if you like the video till now, I think you've reached here, so you liked it. So please like and subscribe to my channel so that you get direct notification for my further videos. Okay, thank you.